is Wim here. We're talking about thermal remote sensing this week.
And Stuart, and I've been doing thermal remote sensing for a long time, and a lot has changed in terms of the technology that Wim will tell you about. And it takes you to a whole new range, the electromagnetic spectrum, where you're seeing the temperature of objects.
And as you might know by now, after reading the chapter and start working on some of these problem sets, that thermal radiation is emitted radiation. It's not reflected radiation, it's emitted radiation from the 3 micrometer to about the 14 micrometer range. So, and a lot of different things you can measure with sensors out with satellites, but also something like this a thermal imager that you see right here. It's a FLIR, a forward-looking infrared sensor, and it's being used to look at cooling and in houses, and basically you point it anywhere, you can look at plants and see what their temperatures are. And if you use a satellite, you can look at the seawater temperature or temperatures of landscapes. And there's a lot of applications in agriculture and in other climate monitoring. If you look at the GOES weather satellite, you see nice images at night, and so at night you can see thermal imagery because the energy is emitted at night as well as during the day. So like with the other sensors you looked at during the day, optical sensors, you can look at vegetation with the reflected radiation, but if there's no sun you can't use that. But thermal you can use day and night basically. So and in terms of background and theory, I hope that you start learning more about black body temperature versus a gray body temperature, where the emissivity of these objects changes as the reflectance kind of changes, and the absorbance and the emission is kind of related to each other. Strong absorber is a strong emitter, so things like that I'd like you to know about, and to also then maybe to correct Landsat or thermal images for emissivity properties, because aluminum, metal has very low emissivity, so you would greatly underestimate the temperature of those surfaces versus surfaces that have high emissivity like water and vegetation. So hopefully you're going to learn a lot about thermal images, and there's many applications. And Stuart has worked in the industry, and his research was with thermal imagery too.
Yeah, it's very interesting. I mean, you can use it for looking at wildlife and sensing their temperatures. You can use it for industrial applications. Rocks, soils, minerals, they have different thermal properties, and in the past people have used it to map the geology of areas. Obviously, if you're looking for things that are hot, like forest fires or geothermal sources or volcanic emissions, thermal data is very useful as well.
And there's many sensors that you can use, so explore some of those. Like I said, this is just a handheld one, but there's airborne airplanes and satellites that use these sensors for lots of applications, and these sensors are quite often designed to measure a certain temperature range related to really hot fires and hot volcanoes versus maybe not as hot of a land surface that's just transpiring, or a building that's not that hot, unless you maybe have some kind of disaster, of course. So enjoy the chapter, reading it. There's a problem set again. There's a lab that makes you convert the radiance to thermal data, and then you can interpret that as well. So Kyle will be talking to you more about that. So see you next week.
See you next week.